Yeah.
Hello, a very good afternoon. No, it's not good afternoon. It's still good morning, even though the day feels long. But welcome back to another session of Streaming School. My name is Leon Hady. I'm a former head teacher who's lucky enough to gather a load of his friends who are teachers to kindly offer some of their time to offer this streaming lesson. Now, these streaming lessons cover a range of GCSE subjects, and more importantly, they also have individual tasks afterwards. So if you're a parent at home looking just to make sure that your child is focused on something, then you've got the education and a small task, and they're in small chunks, maybe just 30 minutes altogether, 20-minute lesson, 10, 15-minute task, just to keep yourself focused, learning, and motivated during this difficult time. It gives me great pleasure, as ever, to welcome my dear colleague, Nisha Hanjan, who is with us again. How are you, Nish?
I'm all good, thanks. How are you?
I'm good. How's everything going with the organisation of everything?
Yeah, it's fine.
For anyone who knows anything about guide education, understand that occasionally I might have a good idea, and then we expect the brilliant team and brilliant people like Nish to actually make those ideas come reality. So they deserve all credit, none so more than the wonderful, the irreplaceable, the hasn't put his camera on, Mr. Michael Scott. How are you, Michael?
I didn't even realize that. Sorry. Good morning, everybody. Morning.
Do you know what's funny? Like sometimes when you're on calls now, because sometimes you get so used to face calling or FaceTiming people or calling people on Skype, and you're doing a video call, but then so many times people have just answered like it's a normal call. So the first thing you see is their ear, and you're just like, yes, no, it's not how I want to start the conversation. What have you got in store for us today,
mate? Let me go on. Sorry, let me turn off. Oh no, my camera should be on.
Oh no, you've just turned something, Mike. So we're gonna see what happens.
Oh, I know why. No, I know why. It's because there you go.
Oh, you're doing the I don't want the government to spy on me thing. What have you got in store for us today, my friend?
So we're looking at some biology. It's going to be photosynthesis today, sir.
Wonderful. All right, the floor is yours, as they say. And really lucky to have you again, Michael. And thank you very much for giving us your time.
No problem. So we're going to kickstart this lesson today with photosynthesis. Photosynthesis is one of the processes that you will have to be able to describe at GCSE, and you should also state the equation for photosynthesis and also understand what can affect the rate of photosynthesis, or what can affect the speed of it. So let's actually break down, first of all, what photosynthesis actually is. Well, photosynthesis is the process where plants make glucose. And plants need this glucose for a number of different functions, for respiration. They store some of this glucose as starch, and they can use the glucose and combine it with nitrates from the soil to make amino acids. And those amino acids can go on to build up proteins. So photosynthesis is a very important process within plants. And you've got to know the equation for photosynthesis. Now, what I'm going to do is give you the equation in words first, and then we'll break it down into its symbol equation. And we'll even add an extra step to see if we can balance it. So first of all, in order to carry out photosynthesis, plants need to take in carbon dioxide, and they take the carbon dioxide in through their leaves. So the leaves have these really small openings called stomata, and the stomata through diffusion can take in carbon dioxide. Now the carbon dioxide combines with water, and the water is taken up through the roots of a plant. And the plant will also need a little bit of help from the sun. Sunlight provides the energy to carry out photosynthesis. And we also have chlorophyll. chlorophyll is the green pigment in the leaf, and it's that green pigment that absorbs the sunlight. And once plants have absorbed the sunlight and they've taken in the carbon dioxide in the water, they can convert these into glucose, which we said before, and also oxygen. A lot of people assume that plants photosynthesize to make oxygen, but this is actually just a byproduct of photosynthesis. And we as humans, we make use of the oxygen, but plants primarily do photosynthesis for the sugar, for the glucose. Now, you could be asked, especially if you're doing the higher paper, you could be asked for what's called the symbol equation. The symbol equation, or the balanced symbol equation, would look something like this, where carbon dioxide is CO2, water is H2O, and glucose is C6H12O6. So glucose contains 6 carbons, 12 hydrogens, and 6 oxygens. And we also release oxygen, which is O2. Now, for the chemists who are watching, the chemists may realize that this equation isn't balanced. And what we mean by that is that we don't have the same number of atoms on each side of the equation. And if we were to balance it, we would put a 6 next to the carbon dioxide, because now we've got 6 carbons, and we've got 6 carbons on this side. So that's balanced. I would also put 6 next to the water. The reason I put a 6 next to the water, because if we do 6 times 2 over the hydrogens, that's 12 hydrogens. And then if we look at glucose, you can see, look, glucose also has 12 hydrogens. And then the final part to balance is we just put a big 6 next to oxygen. The reason we put the big 6 here is that now we've got 18 oxygens, on both sides of the equation. 6 times 2 here would be 12, plus another 6 oxygens is 18. And then 6 times 2 on this side is 12, plus 6 oxygens in the water, that's 18. So we would say that this equation is now balanced. And this is the equation that you would expect, you could be asked to balance this equation at your GCSEs, or you could be asked to recall the whole equation. It is an equation that you're expected to remember. So this is pretty much how photosynthesis works and how it's carried out. Now, you will also need to know what can affect the rate of photosynthesis. In other words, there are certain factors that can make photosynthesis speed up or slow down. This is very useful to farmers, to gardeners, and to industrial farmers, because they want to get the highest yield of their crop possible, and they need to maximize the conditions of photosynthesis to ensure that the plant can respire and store as much starch as possible, to ensure the growth is as maximum as possible also. So we call these limiting factors. Okay, so a limiting factor is anything that affects the rate of photosynthesis. And there are 3 limiting factors that you will have to know at GCSE. The first limiting factor is light. The second limiting factor is carbon dioxide, or CO2. And the third limiting factor is the temperature. And we're going to take a look at these three limiting factors in a little more depth. So let's look at the first one, which is light. So you would typically be given a graph in your exam like this. You would have rate of photosynthesis on, you'd have rate of photosynthesis on the y-axis, and you would also have light intensity on the x-axis. Now, the curve would typically look something like this. Now, we can look at this curve and we can spot 3 points of this curve. At the beginning, I'm going to label A right here. Okay, the point that I've labeled A. We would say here that light is a limiting factor at A. And the reason that light's a limiting factor, because as you increase that intensity of light, as the gradient is getting steeper, the rate of photosynthesis is also increasing. If we look at the second part of this curve, which would be here, which is B, you can start to see here that the rate of photosynthesis is starting to slow down. The gradient is no longer as steep. And then finally, at C, right here, you can see now that light is no longer a limiting factor because the rate of photosynthesis has reached its maximum. You cannot increase the rate of photosynthesis anymore by increasing the light. And you get a very similar curve if we were to look at the concentration of carbon dioxide. Now just put ROP on the y-axis. That just stands for rate of photosynthesis. And again, we get a very similar curve to our light intensity. Again, we can say that at point A, right here, the carbon dioxide is a limiting factor because as you're increasing the concentration of carbon dioxide, you're also increasing the rate of photosynthesis. At point B here, at point B, you can see here that the rate of photosynthesis has started to slow down a little. It's not as steep. And at point C of the curve, over here where the curve kind of flattens out, we would say here that carbon dioxide is no longer a limiting factor. In fact, it doesn't matter how much more carbon dioxide you add past this point. It makes no difference past this point how much carbon dioxide you add because the rate of photosynthesis isn't getting any faster. Now, this is useful to gardeners and to farmers because they may be buying this carbon dioxide and they're not going to want to buy more carbon dioxide than they need. They want to make sure that the concentration is optimum to maximize photosynthesis without actually wasting any of their CO2. And our final one, our final curve, which will be for temperature. And this one has a slightly different curve altogether. So again, I'll change the color so it stands out. On the y-axis, I'll put rate of photosynthesis. And on the x-axis, we'll put temperature. Now the curve for temperature, and this is why I left this one till last, but you'll notice here that the curve for temperature is very different from the other two. And this is because there is what we call a point right here that we would describe as the optimum temperature. Okay, this is the temperature right here where photosynthesis is at its peak. But if you keep increasing the temperature past this point here, okay, if you keep increasing the temperature past this point, you can kind of see how the rate of photosynthesis suddenly just plummets. It just drops until, we hit this point here where no photosynthesis is taking place. And the reason for this is that photosynthesis is controlled by enzymes. Okay? The process of photosynthesis is controlled by enzymes. Now, these enzymes get destroyed, or a more scientific term is they get denatured. And the denaturing of these enzymes tends to occur above 40 degrees. So the optimum temperature for photosynthesis would typically be anywhere between 37 degrees and 40 degrees Celsius. Anything above this will cause the enzymes to denature, which will ultimately slow down the rate of photosynthesis. And again, it's important for farmers and gardeners to understand these three limiting factors if they want to maximize their rate of photosynthesis, and in order to grow the best crop and receive the best yield of their crops. So this is all about photosynthesis that we've looked at, and hopefully you should be able to use this to now answer the question on photosynthesis at the end. Back to you guys.
Thank you so much, buddy. Thank you so much.
Yeah, not a problem.
Yeah. Well, what does the rest of the day look like for you?
I have got a few more online tuitions today, and then I'm just I'm catching up on some books that I've bought and not had the chance to read.
I was the second person to mention books and reading today. I haven't actually had a chance to pick up anything in this whole time.
Yeah, I've got a few books that I've accumulated over the years and never picked them up. So now during the lockdown, it's a good time to pick them up and read them. So yeah, I'm gonna be doing that today.
I feel ashamed, Michael. Amazon was the biggest provider of books before it started doing everything else. And obviously now does everything else, and I've just been buying everything else, not the books. I need to get back to basics.
Yeah, most of the books are these are all Christmas presents and birthday presents. So I'm going to sit down today and I started one yesterday, so I'm going to read a few more chapters today.
Do you have
broaden my
horizons? How much I'm censoring myself because I know we're live. The amount of jokes I've got for that, but I'm just hold it down. All right, Nish, thank you so much, Mike. Nish,
take care, guys. Take care.
To you. Thank you. Have a great weekend, buddy. Catch you in a bit.
Bye.
Nish, that was hard. I struggled there. I actually struggled. All me and Michael do is joke, so it's very hard to be serious for 1 minute. Yeah. It's like literally that was like an addict, coming near something like I just got to turn away. All right, so the lead out is yours.
All right, cool.
We've got another science lesson coming up, haven't we?
Sorry?
We've got another science lesson coming up, haven't we?
Yep, got a chemistry lesson coming up next. So here is the optional task for this biology science lesson. Is why does temperature affect the rate of photosynthesis? So if you've missed out on any videos, want to go back and take a look, you can go on Facebook and on YouTube. All the links to any resources are on there as well. And up next we have chemistry.
Brilliant. Thank you so much, my dear. I will see you in 20 minutes.
Thank you.